So let's continue with an example of congruent angles and replacing angle measures and solving for variables here. Here we were told that angle 1 is congruent with angle 2. Well, if going to the next line, if angle 1 is congruent with angle 2, that means the measure of angle 1 equals the measure of angle 2. That's your first step. Now I'm going to do substitution. Instead of the measure of angle 1 here, I am instead going to replace what the measure of angle 1 is equal to. Bring down your equal sign. And now instead of the measure of angle 2, I'm going to replace that with what the measure of angle 2 is equal to. So now I have an algebraic equation and I can solve for x. So I want to get all the x's on one side of the equal sign, so I'll subtract 2x from both sides. They'll cancel. I bring down the 15, bring down the equals. 3x minus 2x is 1x. Bring down your minus and bring down your 2. Now I want to get x by itself, so I'm going to add 2 to both sides. Bring down the equals, bring down the x, and they cancel. So I've just solved for x. X equals 17. Now, if they had asked what is the measure of angle 1 or what is the measure of angle 2, I'd have to substitute that back into either 2x plus 15 or 3x minus 2 to get the measure of the angle. This just asked what is the value of the variable. All right, some other types of terms. A bisector of an angle is a ray, or could be a line segment, that separates the angle into two congruent angles. So if there's a point on the interior of an angle such that the two smaller angles are congruent, that must mean that the ray from the vertex through that point is a bisector. So, if the ray creates congruent angles, it's a bisector. If the two angles are congruent, then it's a bisector. All right, so here we have an example of an angle bisector. How do I know that the ray NP is an angle bisector? This has two arcs and this has two arcs. This tells me that that marking tells me that those two angles are congruent. Just by that marking, I would know that NP is a bisector, an angle bisector, and I would know that the measure of angle MNP would equal the measure of angle PNQ. Complementary angles. Complementary angles have a sum of 90 degrees. If the sum, when you add them together, equal 90, they are complementary angles, or they're the complements of each other. How do we know that a 37 degree and a 53 degree angle are complementary? What is 37 plus 53? 7 and 3 is 10, carry your 1, 90 degrees. And two angles are called the complements of each other if their sum equals 90 degrees. So complementary angles, the sum equals 90 degrees. And then right after you learn about complementary angles, then you learn about supplementary angles. Supplementary angles, their sum will equal 180 degrees. and the angles are supplements of each other. So if I have the measure of angle A is 10 degrees, and the measure of angle B is 170 degrees, I would say angle A and angle B are the supplements of each other. Why? Because 10 plus 170 equals 180. And we'll have a little practice here. Given that the measure of angle 1 is 29 degrees, what's the complement, named x, of angle 1? So the measure of angle 1 plus the measure of angle x, complements will always equal 90. Complements, the sum equals 90. So instead of the measure of angle 1, I'm going to replace measure of angle with 1 with what it's equal to. 29 plus the measure of angle x equals 90. And we want to get the measure of angle x by itself, so I'm going to subtract 29 from both sides. The measure of angle x is, and 90 minus 29 is 61 degrees. The complement to a 29 degree angle is a 61 degree angle. Why did I call it x? Because right here in the problem, they said to call it x. All right, they want us to find the supplement angle named y, the supplement to angle 1, and it's named y. So the measure of angle 1 plus the measure of angle y, since they're supplements, is going to equal 180. And again, replace anything that's on one side of the equal sign, you can always replace it with the other side of the equal sign. You bring down the plus, bring down the measure of angle y, bring down the equals, bring down the 180. And now we're going to subtract 29 from both sides. And we would get the measure of angle y is equal to 151. Okay. Another relationship between a pair of angles are called vertical angles. So we have adjacent angles, we have congruent angles, we have complementary angles, we have supplementary angles, and now we have vertical angles. Vertical angles. When two lines intersect, the two non-adjacent angles, the two angles that are not touching each other, are the vertical angles. So angle 7 and angle 8 are vertical angles. Angle 5 and angle 6 are vertical angles. They're non-adjacent, they're not touching. All right, and as you look at these, the measure of angle 7 and the measure of angle 5 must equal 180 because when you add them up, you get the straight line. Also, the measure of angle 7 and the measure of angle 6 must equal 180 because when you add them up, you get a straight line. So our question down here was, if the measure of angle 7 was 30 degrees, what's the measure of angle 5? 7 and 5. The measure of angle 7 plus the measure of angle 5, since they make a straight line, they're going to have to equal 180 degrees. Replace measure of angle 7 with what it's equal to. 30 plus the measure of angle 5 equals 180. And subtract 30 from each side. The measure of angle 5 must be 150 degrees. And it actually does look like an obtuse angle. So what's the measure of angle 8? What's the measure of angle 8? Well, For the same reasoning, the measure of angle 7 plus the measure of, the measure of angle 6 would have been the same as the measure of angle 5. But what's the measure of angle 8? Well, the measure of angle 5 plus the measure of angle 8 also have to equal 180, and we just found out that was 150. So subtract 150 from both sides. So angle 7 was 30 degrees, and you know what? The measure of angle 8 is also 30 degrees. That is because vertical angles are congruent. Vertical angles, so angle 7 and angle 8, are congruent. 7 and 8 have the same measure, 5 and 6 have the same measure. So that's a postulate. You can just use that, the vertical angles are congruent. All right, so what if we are given some algebraic expression for vertical angles, and we know vertical angles are congruent? We might have to solve an algebra problem. Let's say one of the vertical angles, the measure is x plus y equals 5. And let's say for the other angle, we're told that 2x minus y equals 7. All right, so what we're going to do is line up our equations, and if you add vertically, you'll see that positive y and negative y will cancel each other. And if you